Hello out there, welcome to this tutorial again on mappings and functions. In this video we'll be looking at composite mappings or composite functions. So we are given two functions, given G and H as two mappings in which the codomain of G is the domain of H. Diagrammatically we have the two mappings here, and if you look at it, A is mapped to H, B is mapped to E, and C is mapped to F, D is mapped to G. And for H we have E is mapped to J, F is mapped to I, G is mapped to L, and H is mapped to K. So the mapping G takes an element in X and produces an image in Y. The mapping H takes an element in Y and produces an image in Z. The mapping G, that is GOH, which takes an element in X and produces an image in Z via Y, is called composite mapping. It is sometimes written GH. So we'll be solving some problems on this composite mapping. So we start the first problem. If F is a mapping and Y is a mapping, then on the set of real numbers, and they are defined by f of x is equal to 2x plus 5 and g of x is equal to x squared minus 2x, find A, fog, and gulf. We start with A. So for problem A, we have to find fog, that is a composition of mappings of F and G, which is interpreted as G first, then F. So with this interpretation, it is F of G of X. Then we now bring in G of X, we hold F, then bring in G of X, which is x squared minus 2x. Then we now go to F of X. Wherever we see X, we put x squared minus 2x. So from here, for 2x plus 5, we are going to have it as 2 into x squared minus 2x, then plus 5. If you look at it now, 2x plus 5, 2x plus 5. We have replaced the x in the original function of f with x squared minus 2x. So we simplify, expanding the bracket, 2x squared minus 4x plus 5. And that is the end of solution to problem 1a, that is GF, the composition of F and G. So we go to problem 1b. For problem 1b, in the same way, it is f of x first, then g of x. So we bring it as gf of x, that is f of x first, and our f of x here is 2x plus 5. So we have g 2x plus 5. Then we go to g of x. Wherever we see x, we put these brackets. So since we have x squared minus 2x, it means 2x plus 5 squared minus 2 into 2x plus 5. So expanding this bracket, the method of expanding this bracket is to multiply 2x by 2x. That will give us a 4x squared. Then we now multiply 2x by 5, which will give us a 10x. Then multiply by 2 will give us a 20x. Then you come to the second term now and multiply it by itself to give us a 25. Then the second bracket, we have a 4x plus 10. Collecting the like terms, I have 4x squared, 20x plus 4x gives 24x, 25 plus 10 gives 35. So that's the end of solution to problem 1, since we have solved problems 1A and B. So we go to problem 2. In problem 2, if f, g, and h are mappings defined on the set of real numbers by f of x equal to x minus 3, g of x equal to 2x squared, and h of x is equal to 3x plus 1. So we start from the A part of the problem. Fog, that is gf, as we just explained, g of x first, then f. So we have f into g of x, and our g of x is 2x squared, so we have f into 2x squared. So from here, this is x minus 3, so we replace the x with 2x squared, so we have 2x squared minus 3, and we cannot simplify further. That is the solution to problem 2A. For problem 2B, we have gh. For gh, it is h of x first, so we have g h of x, and our h of x is 3x plus 1, so we have g of 3x plus 1. We now go to g of x. Wherever we see x, we put 3x plus 1. So since g of x is 2x squared, it means 2 into 3x plus 1 squared. So expanding this, we have a 2. So here we have 3x times 3x, which gives 9x squared. 3x times 1, that is 3x multiplied by 2 will give us 6x, and 1 squared is 1. Then finally expanding, we have a 18x squared plus 12x plus 2, which gives gh. Then we go to C, that is fgh. This fgh means h of x first, followed by g of x, and then f of x. We can quickly look at it as fgh of x, and we have already gotten gh of x, which is 18x squared plus 12x plus 2, which is going to give us f into 18x squared plus 12x plus 2. Then we go to the function f. Wherever we see x, we replace it with 18x squared plus 12x plus 2, so that we now have it as 18x squared plus 12x plus 2, which represents this x, then minus 3. Expanding this bracket, we have 18x squared plus 12x minus 1. And that is the end of solution to problem 2. So we go to problem 3. For problem 3, if f, g, and h are mappings defined on the set of real numbers by f of x equal to 2x plus 1, g of x equal to x minus 1, and h of x equal to 5x plus 3, find the value of x for which a, fg is equal to hg, b, fgh is equal to 0. So we start with problem A. We have to find fg first, so that is composition of f and g. So we now have g first, so that is going to give us fg of x, and our g of x is x minus 1. So we have f of x minus 1. So having gotten this, we go to f of x. Wherever we see x, we put x minus 1. So since we have 2x here, it is going to be 2 into x minus 1, then plus 1. Expanding this bracket, This 2 times x gives 2x. 2 times -1 gives -2 plus 1. So we now have it as 2x minus 1. Since -2 plus 1 gives -1. So we are done with FG. We look for HG. That's composition of the mappings H and G. So in this case, the G comes first, then before H. So we have HG of x, and our G of x is x minus 1. So we have H into x minus 1. And we now go to H of x. Wherever we see x, we replace it with x minus 1. So that from here, 5x means 5 into x minus 1, then plus 3. We expand the bracket, 5x minus 5 plus 3. I have used this 5 to multiply everything inside the bracket, which does not affect this 3. So final answer will give me 5x minus 2. But we have to find the value of x for which FG is equal to HG. So to do that, our FG is 2x minus 1. So we have it 2x minus 1 on the left hand side, and our HG is 5x minus 2, which gives 5x minus 2. Then solving this linear equation, we have a 2x minus 5x is equal to -2 plus 1. So 2x minus 5x gives -3x. So, and -2 plus 1 gives -1. So that we now have -3x is equal to -1. Dividing both sides by -3, x is equal to 1 over 3. And that is the end of solution to problem 3a. So we are going ahead to solve problem 3b. So in this problem, the interpretation is h of x first, followed by g of x, and then f of x. So what we do, we have to simplify what we have inside the bracket first. That's going to give us GOR, that is gh. So that's gh of x, and our h of x is 5x plus 3. So g of 5x plus 3, and we now go to g of x. Wherever we see x, we put 5x plus 3. That will give us 5x plus 3 minus 1. Then simplifying this, we have 5x plus 2, which gives this. Then we now go ahead to find FGH. That's going to give us FGH of x, and we have gotten our GH of x to be 5x plus 2. That will now give us f of 5x plus 2. We go to our function f. Wherever we see x, we replace it with what? 5x plus 2. Like there's 2x here, so it's going to be 2 into 5x plus 2, then plus 1. Expanding this bracket, I have 10x plus 4 plus 1, which will give us 10x plus 5. Then we now go ahead to see if FGH is equal to 0, what is the value of x. So FGH is equal to 0, which means 10x plus 5 is equal to 0. Solving this linear equation, 10x is equal to -5. I have taken the positive 5 here to the right hand side, dividing both sides by 10. X is -half. Yeah, x is -1 over 2, because when we get to the right hand side, it becomes 5 over 10, and 5 over 10 is 1 over 2. So, and attach the negative sign. So we have done justice to problem 3. We go to problem 4. For problem 4, If f and g are mappings defined on the set of real numbers by f of x is equal to 3x minus 1 and g of x is equal to x plus 1 all over x minus 1, where x is not equal to 1. Immediately x is equal to 1, the function diminishes, so x is not equal to 1 there. So we have to find a f g of 2 and g f of negative 2. Wow. So we start with a. First and foremost, we have to find fg. After finding fg, before we now substitute whatever function we get from there, we substitute in 2 for x. So we go, this is fg of x, and our g of x is x plus 1 over x minus 1. So we have f into x plus 1 over x minus 1. So this is what we are going to substitute now into this, so that whenever we see x, we put this bracket. So we have it as 3 into x plus 1 over x minus 1 minus 1. Here we are going to simplify this fraction. This is the LCM. We take it as LCM. This LCM divided by this gives 1 times 3. We have a 3 into x plus 1, and again x minus 1 divided by 1 gives x minus 1, multiplied by negative 1. We have negative 1 into x minus 1. So we simplify the numerator. This is 3x minus x here. If we expand this, 3 times x will give me 3x, negative 1 times x will give me negative x. So 3x minus x gives 2x. 3 times 1 gives 3, negative 1 times negative 1 will give me positive 1. So the 3 here plus 1 will give 4 over x minus 1. We found fg, so we go ahead to find fg of 2. We come here, wherever you will see x, we put 2. So that's going to give us 2 into 2 plus 4 over 2 minus 1. 2 times 2 gives 4 plus 4, 8 over 1, which gives our final answer as 8. So that is the end of solution to problem 4a. We go to problem 4b. Also, we find gf first. That's going to be gf of x, and our f of x is 3x minus 1. So we have g into 3x minus 1. So we go to g of x. Wherever we see x, we put 3x minus 1. So that will now give us 3x minus 1, then plus 1 over 3x minus 1, then minus 1. So simplifying the numerator, negative 1 plus 1 gives 0. So the numerator is 3x. Negative 1 minus 1 gives negative 2. So we have it as over 3x minus 2. Also, we go ahead to substitute in negative 2 in the function. So we have gf of negative 2 to be 3 into negative 2 over 3 into negative 2 minus 2, which will give us a negative 6. 3 times negative 2 gives negative 6 minus 2 gives negative 8. So simplifying this to the simplest form, we have our final answer as 3 over 4. And that is the end of solution to problem 4. And invariably, this is the end of this tutorial. I hope you enjoyed it. Please check the description section of this video on our YouTube channel to get links to other videos on composite mappings and some other valuable topics on our YouTube channel. Please remember to subscribe. Until we come your way again, goodbye.